morning, children. I hope you have gone through the properties as well as the exercise questions thoroughly. Today's topic is representation of rational numbers on a number line. If you see this topic, the word number line is very familiar to you. That is, I will explain what is a number line, how can you represent whole numbers, natural numbers, integers, and how you were taught in smaller classes to add, subtract, multiply and divide on a number line, as well as to check the rule by which the numbers which is bigger than each other, what will be the position of those numbers on a number line. Let's review back the concept of number line. A number line is used for representing any set of numbers. That is, if you consider a straight line and fix one of the point as 1 and at equal distances, if you plot numbers here, this number line will represent a number line for natural numbers. Why? Because natural numbers start from 1, 2, 3, etc. and it extends infinitely onto the only one side. The next is the set of whole numbers. How do you represent the set of whole numbers? By a number line, and the initial point will be 0. Equal distances, you will plot points which will represent the consecutive numbers as 1, 2, 3, etc. and so on. Then how do you represent integers on a number line is, you will take a line which is extending on both the directions. Any one point you will take it as 0. It need not be compulsorily in the middle because a line cannot be measured. Equal distances, you will take points. Towards the right side, you will plot the positive numbers, and towards the left side, you will plot the negative numbers. Thus, this number line will represent the set of integers. And now, your concept today is representation of rational numbers on a number line. Before that concept, let me just revise with you how you were adding, subtracting, multiplying and dividing simple small numbers when you were in smaller classes by using number line. Let's see how to add 2 plus 3 on a number line. You have learned like draw a number line, fix a point 0, and you will take equal distances. The main logic on a number line is distance between the units have to be equal. So 1, 2, 3, 4, 5, 6, 7, 8. For addition, the first shifting is from 0 to the first number 2. Then 3 steps forward. 1, 2, 3 and you will get. So for addition, you move forward. What about subtraction? If you are asked to subtract 5 minus 2, the same way you will draw a number line, plot the points 1, 2, 3, 4, 5, 6. 6. And 5 minus 2 is, the first concept is first directly to 5 and then move back. That means 2 steps you will move back or count backward. So you will give subtraction answer as 5 minus 2 is equal to 3, and what you have done is move backward. The answer is 3. Same way, how do you multiply? The multiplication is related as repeated addition. It is repeated addition. That means 2 plus 2 plus 2 is the same as 2 repeated 3 times. That is the concept. So, if you want to get 2 into 3, you can work out 2 ways. Since it is commutative, that is 2 into 3 and 3 into 2 are equal, you can do either on the number line, equal distances 3, 4, 5, 6, 7, 8. Either 2 into 3 is the same as either 2 units at a time 3 times. That is 2, another 2, another 2. That will also give you an answer. Or you can take, since multiplication is commutative, you can also do it as equal steps of 3 but only 2 times. Still you will get an answer. So 2 into 3 or 3 into 2 will give the answer as 6. Similarly, how do you divide? You have to divide 12 divided by 6. How do you use number line? You will use a number line, and division is considered as repeated subtraction, and the answer is how many times you are subtracting. The number line will have up to 12, 10, 11 and 12. Then from 0 to 12 you will move 1 step forward, and subtraction means move backward. 6, that means up to 6 one time, another 6 one time. That means you have done 1, 2. That means 2 times you have come backward, or the answer is 2. That is how many steps you will move back to reach 0. You have taken 2 times from 12 first to 6. Again 6 to 0 it became. That means for 2 times you have done. So the division answer is 2. Same way, how to compare numbers on a number line. If you have a number line 1, 2, 3, 4, 5, 6. How do you know from the number line that 6 is greater than 2 is 6 greater than 2? How do you confirm? 6 lies towards right of 2. That means if any number towards right of another number, it will be definitely greater than 2. Same way, comparing 4 and 0, 4 is towards right side of 0 on number line. Therefore, 4 is greater than 0. This concept is useful for integers. if you see number line of integers, you can very easily remember which number or the comparison of integers if you keep a number line in your mind. Towards right, which shows that if you have a number line with negative integers in this format, very clearly you know that -1 is towards right of -5. -1 greater than -5 because -1 is towards the right side. So the general concept on a number line is any number towards the right position will be greater than the number in the left position. So for integers, it will be very helpful to you to identify which integer is greater than the other integer. Both the topics of today, what we are planning to do is again repeated next year in chapter 1. If you see the video of class 9, what I have posted in class 9, the same topics of how to represent rational numbers on a number line, how to find the rational numbers between any two rational numbers, you can see there very clearly, which shows that the topic is very important, and if you understand this topic this year, it will be useful for you another 2 more years. Now, representation of rational numbers on a number line. As you have seen, a number line, always you plot the number 0, and if you have to plot a rational number 3/4 on a number line. Now, the denominator of the rational number is 4. That means you have to divide the part between 0 and 1. The part between 0 and 1 into 4 equal parts. This is the basic of plotting a rational number on a number line. That is, between 0 and 1, you have to divide it as 4 equal parts, as the denominator of this rational number is 4. That means you will make it into 4 equal parts, and each part will be 1/4, 2/4, 3/4. This is 4/4, 1. So this point A represents the rational number 3/4. But if you have bigger numbers, or if you have rational numbers with denominator as 12 and 5/12, if you are asked to plot 5/12 on a number line, the same way if you divide 0 and 1, it will be difficult for you to find equal distribution between 0, 1 into 12 equal parts. To avoid this, we can follow a general way of dividing the unit between 0 and 1 into equal parts as follows. Represent the following rational numbers on a number line. There are 5 different questions. If you check the denominator, 5, 12, 11, 6, 9 and different denominators I have given to you. The question is, represent 3/5 on a number line. Using scale, you are drawing a line Select any one point as 0. The denominator is 5. Now, you have to take on your scale, that is 1 unit, you can take it as 1 centimeter here because the number 5 is not a very big number. So, each 1 centimeter you can take 1, 2, each 1 centimeter you can plot the points and keep. The first point will represent 1 by 5. Second point will represent 2 by 5. Third point will represent 3 by 5. Fourth point is 4 by 5. And the fifth point is 5 by 5, 1. That means between 0 and 1, we could easily divide into 5 equal parts. And the point A represents 3 by 5. So the idea is start counting from 0 as the first point as 1 by 5, 2 by 5, 3 by 5, 4 by 5, 5 by 5, 1. In this itself, if you have to take one more point as 7 by 5, continue as 6 by 5, 7 by 5, 8 by 5, the next multiple of 5, 9 by 5 and 10 by 5 will give you the 2, that is 6 by 5, 7 by 5, 8 by 5, 9 by 5, 10 by 5 is 2. So if you want to plot as many points on this number line, you can do it. The only consideration is each 1 centimeter you take with the multiples of 5 so that you will reach here into the whole numbers. The next is how to plot 7 by 12. The idea is the same, 0. Now, since 1 centimeter will be little far, what you can do is each unit you take it as half centimeter or that 5 millimeter. Start counting as 1 by 12, read with the denominator. 1 by 12, 2 by 12, 3, 4 by 12, 5 by 12, 6 by 12, 7 by 12, 8 by 12, 9 by 12, 10 by 12, 11 by 12, 12 by 12, you will mark it as 1 right here, 12 by 12, and the point is 7. So 1, 2, 3, 4, 5, 6, 7. You can plot it as 7 by 12. Even if you write all the numbers, there is no harm. But you give a letter there. B represents 7 by 12 on the line. This naming the point is very, very, very important. Similarly, 8 by 11. Number 3, 8 by 11. Half centimeter, you can take it as, say it as 1 by 11, 2 by 11, 3, 4, 5, 6, 7, 8, 9, 10, 11 by 11, 1. So which will be the point representing 8 by 11 is 1, 2, 3, 4, 5, 6, 7, 8. This point will represent 8 by 11. Point C represents 8 by 11. Towards negative side, minus 5 by 6. There is no harm if you plot only 0 and towards left. But it is compulsorily towards the left. If the denominator is only 6, you can take 1 centimeter as 1 unit. 1 by 6, negative 1 by 6, negative 2 by 6, negative 3 by 6, negative 4 by 6, negative 5 by 6, negative 6 by 6, negative 1. That is between 0 and 1. You have taken into 6 equal parts, minus 5 by 6. plot this point, give a letter E. E represents point minus 5 by 6 minus 2 by 9. There is no harm if you take only the left side, or even if you want to plot one point there, but left side is enough. Same way, the number is 9. Take half centimeter as 1 by 9, 2 by 9, 3 by 9, 4, 5, 6, 7, 8, 9. Remember that you should reach till 9 by 9, 1. Till 6 by 6, 1. 11 by 11, 1. 12 by 12, 1. 5 by 5, 1. Then only you can show that you have divided between 0 and 1 into equal parts. So here it is 9, or it is minus 9 by 9 minus 1, and the point minus 2 by 9. This represents minus 2 by 9. Give the naming as G. G, point G represents minus 2 by 9 on the number line. I hope you understood. As per the denominator, take half centimeter or 1 centimeter. Start from 0 towards right for positive numbers and towards left for the negative rational numbers. Let me ask you, how many whole numbers between 0 and 5? Between does not include 0 and 5. How many whole numbers are there between 0 and 5? Is 1, 2, 3, 4. That means there are 4 whole numbers between 0 and 5. 1, 2, 3, 4. How many natural numbers between 7 and 10? Is 8 and 9. That is, there are 2 natural numbers between 8 and between 7 and 10. How many integers between minus 3 and plus 6? Is minus 2, minus 1, 0, 1, 2, 3, 4, 5. That is 1, 2, 3, 4, 5, 6, 7, 8. There are 8 numbers. Why did I show all this? Is between any 2 whole numbers given, there are only fixed numbers of whole numbers in between them. Same way, between any 2 natural numbers, the number of natural numbers are fixed. Or between any 2 integers, there are only finite number of integers. That is, there are only finite. Finite means countable. Finite means countable. There are only finite number of whole numbers, natural numbers and integers between any 2 of them. Any 2 of them. Now, let's come to the position of rational numbers. So, your topic under consideration is between any 2 rational numbers, how many rational numbers you can find. Let's go in detail with that. Let's discuss in detail how many rational numbers between any 2 rational numbers and how to find them. How do you find rational numbers between any 2 rational numbers? Let me take a small example, or a very, very small example of numbers 2 and 3. Let's see what is a rational number. Any number of the form P by Q, where P and Q are integers. How do you represent 2 and 3 as rational numbers? You can write 2 as 2 by 1, 3 as 3 by 1. That is the first method. And now, if you know that 2 and 3 as whole numbers. Between 2 and 3, you can see 2.1, 2.2, 2.3, 2.4 up to 2.9. Again, between 2.1 and 2.2, you can write it as 2.11, 2.12, 2.13 and so on. That is, between 2.2 and 2.3 also, as many numbers you wanted, you can write. Same way, between 2.11 and 2.12, let me write in detail once again. Between 2 and 3, the first simple division can be 2.1, 2.2, 2.3, 2.4 and so on. Between 2.1 and 2.2, the simple division can be 2.11, 2.12, 2.13 and so on. Between 2.11 and 2.12 can be 2.11, 2.111, 2.112, 2.113 and so on. Between 2.111 and 112, you can divide as 2.1111, 2.1112, 2.1113 and so on. Thus, it is only numbers between 2.1 and 2.2. What about the remaining set? Which shows very clearly that between any two rational numbers, there are infinite number of rational numbers between any two rational numbers. Any example if you represent it in the decimal form, you will understand that. Now, how to find them? There are two methods of finding numbers, rational numbers between any two rational numbers. I will explain both the methods and I will suggest you which method you will apply for the exercise questions. If I find 7 rational numbers between 2 and 3. Now, let's avoid decimals and we can write rational numbers as fractions. You see how we are writing is 2 can be represented as 2 by 1, 3 can be represented as 3 by 1. Between 2 and 2 by 1 and 3 by 1, you cannot find a number which is consecutive to that. You can multiply both the numerator and denominator by 10 so that 20 by 10 and 30 by 10 is the same rational number as 2 by 3. Or if you multiply 200 by 100, 300 by 100, it remains the same rational number. Or you can make it as 2000 by 1000, 3000 by 1000, the same number it represents. So, between any two rational numbers, as many rational numbers you can insert. Our question is just to find 7 rational numbers. Any order, you can take the 7 rational numbers as 21 by 10, 22 by 10, 25 by 10, 23 by 10, 27 by 10, 29 by 10 and 24 by 10. 1, 2, 3, 4, 5, 6, 7. If you have 9 numbers. In case you want to find the 17 rational numbers, you can go for the denominator with 100. If you want 27 rational numbers also, you can take this option. So, any rational number can be multiplied and divided by the multiples of 10, which will give you a rational number, and between those two rational numbers, you can insert as many rational numbers possible. This is another way of explaining the concept that between any two rational numbers, there can be infinite number of rational numbers. The question is, find 5 rational numbers between 2 by 5 and 7 by 5. After 2 by 5, 3 by 5, 4 by 5, 5 by 5, 6 by 5. So 4 of them you can easily get, but you need 5 of them. There is no harm if you just multiply, as 2 by 5 is the same as 20 by 50 and 7 by 5 is the same as 70 by 50. Between 20 and 70 you need only 5 of them. So any 5 rational numbers are 32 by 50 or 46 by 50, 53 by 50, then 29 by 50 and 64 by 50. Any 5 rational numbers you can write, any random order, it should be between 20 and 70. That is the only rule between that. Now, how do you find rational numbers when the denominators are different? How do you find rational numbers between 1 by 3, 5 rational numbers between 1 by 3 and 1 by 4? So what is the method of making the denominators same? Is to find the LCM of 3 and 4. 3 and 4 do not have a common factor. LCM of 3 and 4 is 12. That is 1 by 3 is the same as 4 by 12. 1 by 4 is the same as 3 by 12. Still, between 3 by 12 and 4 by 12, you cannot get a rational number in the fraction form. What you can do is 3 by 12 and 4 by 12 express as into 10 or into 100, that is 30 by 120, 40 by 120. You can get 9 rational numbers as 31 by 120, 35 by 120, you need only 5. In case you need more, multiply by 100 or multiply by 1000. This is the method of inserting rational number between any two rational numbers. 35 by 120, 37 by 120, 39 by 120 and 33 by 120. So, this is the first method of inserting rational numbers by multiplying the numerator and denominator by multiples of 10, 100 and so on, after making the denominator as the same number. The second method prescribed is to find the average. What is the meaning of average? The average of two numbers is sum of the numbers divided by 2 because there are two numbers. Suppose there are 3 numbers, average is sum of all the numbers divided by 3. Here between 2 numbers only, so you are finding the average of 2 and 3, that would be the first number. So what will be the average of 2 and 3 is 2 plus 3 by 2, which is equal to 5 by 2 is equal to 2.5. That is, the first number is 2.5. Again, you can find the average of 2 and 2.5. That is 4.5 by 2, which is equal to 2.25. 2.25. You can get the average of 2.25 and 3. 2.25 plus 3.0, that is 5.25 by 2 is the same as 2.625. It's another number 2.625. That is, any two numbers you are taking, you find the average of those numbers will give as many rational numbers between the numbers. But preferably, the first method is better. You can make the denominator same by LCM method. In case it is different, then multiply by the multiples of 10, 100, 1000 depending on the number of rational numbers to be found out. Exercise 1.2. All questions are of the pattern what I have done, the explanation. So I prefer all of you to do the sums and then only refer to the video. And question number 2 onwards, there cannot be a fixed answer because there are so many rational numbers between two rational numbers, so all your answers may differ. Only the method I will explain. Once again, represent on a number line. First one 7 by 4 and minus 5 by 6. As I told you, depending on the denominator, you draw a number line, divide as 1 centimeter or half centimeter. You can take 4 equal parts as 1 by 4, 2 by 4, 3 by 4, 4 by 4 as 1, 5 by 4, 6 by 4, 7 by 4, 8 by 4 as 2. Now you can mark 7 by 4 and A represents the position 7 by 4. Similarly, minus 5 by 6. Question number 2. Find 5 rational numbers smaller than 2. If you observe the number line itself, there are negative numbers, so many negative integers because all integers are rational numbers. You can just mention any 5 rational numbers means 1, 0, any integer you can mention as a rational number. That's why the answers may not be the same. Each child will have different answer. Find 10 rational numbers between minus 2 by 5 and 1 by 2. LCM of 5 and 2 is 10. You can write it as minus 4 by 10 and 5 by 10. You need 10 rational numbers. That means between minus 4 and 5. That is, you can take it as minus 3 by 10, minus 2 by 10, minus 1 by 10, 0 and so on. Minus 3 by 10, minus 2 by 10, minus 1 by 10, 0, 1 by 10, 2 by 10, 3 by 10, 4 by 10. Now, in 1, 2, 3, 4, 5, 6, 7, 8 only. In that case, you can make it as minus or you can make it as many numbers, 40. Now, you can write it as 41 by 100, make the denominator as 100. You can write as many numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 42 by 100. So, this is a method of adjusting the denominator in case you are getting less number of rational numbers. Question number 5. Find 5 rational numbers between 2 by 3 and 4 by 5. The LCM of 3 and 5 is 15. The LCM has to be found out. Make the rational numbers into the same denominator. Multiply by 10 and get the answers. Minus 3 by 2 and 5 by 3. Minus 3 by 2 and 5 by 3. Again, LCM is 6. 1 by 4 and 1 by 2, LCM is 4. Write 5 rational numbers greater than minus 2. What are the numbers greater than minus 2? Towards right. As many positive integers you can write because integers also are rational numbers. Find 10 rational numbers between 3 by 5 and 3 by 4. Again, LCM is 20. You can find you can convert each rational number with the denominator 20 and write 10 rational numbers. As I told you, all your answers will be different. We will check only the method when the teachers do examination correction.